All right, so now we want to talk about the present value of an annuity due, and we denote that with this notation here, A sub, and then in parentheses n comma due, and it looks very similar to our previous formula. And again, the only addition is that we are multiplying the entire thing by the expression 1 plus I, where I represents our interest rate. Example 5 says, a lottery prize worth $1.2 million is awarded in payments of $10,000 at the beginning, notice it says beginning, of each month for 10 years. Suppose money is worth 7.8% compounded monthly. What is the real value of the prize? So we are solving for the present value of the annuity due. We don't know what that is. We do know the regular payment amounts will be $10,000. We know that the interest rate is 7.8%, and we are compounding monthly. So if we divide that, we would get 0.0065, and then the number of time periods, well, we are compounding monthly, and we are doing that for 10 years, so n would equal 120. So let's go ahead and plug in these values. So is equal to 10,000 times 1 minus 1 plus 0.0065 to the negative 120th power over 0.0065, and we are going to multiply this whole thing by 1.0065. Okay, so let's throw that into our calculator. So you should get that lottery prize, in reality, the real value ends up being about $836,843.55. Okay, I forgot to box my answer. Example 6 says, suppose that a court settlement results in a $750,000 reward. If this is invested at 9% compounded semi-annually, how much will it provide at the beginning of each half year for a period of 7 years? So we know the present value of our annuity due is $750,000. We know that the interest rate is 9%. Compounded semi-annually, so that's going to be 0.09 divided by 2, which gives us 0.045. We know that the number of terms is 7 years, and that's semi-annually, so 7 times 2 is 14. And R is the thing that we are solving for, so we don't know the regular payment amounts. So let's go ahead and plug in our value. So we get 750,000 equals R times 1 minus 1 plus 0.045 to the power of negative 14 over 0.045. And we're going to multiply all of that by 1.045. And so R ends up being $750,000 divided by 1 minus 1.045 to the negative 14th power over 0.045. 0.045 times 1.045 there. And if you throw that into your calculator, you should get that the semi-annual payments for this settlement is approximately $70,205.97.